Welcome back to Beyond Binary, the channel where we uncover the technologies reshaping humanity's future. Today, we're diving into one of the most ambitious scientific races in history, the race for quantum supremacy. Forget the space race of the 20th century. The quantum race of the 21st is just as fierce, just as geopolitical, and possibly even more impactful. At the center of this competition stand three giants: Google, IBM, and India. Each of them is chasing the same goal, building machines that can do the impossible. But who's really ahead? Let's find out step by step through 10 powerful facts that reveal the truth about this race. Fact number 1, Google lit the spark. In 2019, Google's Sycamore processor solved a random number generation problem in 200 seconds, a task it claimed would take a classical supercomputer 10,000 years. Critics argued the problem was trivial. But here's the point. It was like the Wright brothers' first flight. Short, shaky, and seemingly useless, but proof that flight was possible. Fast forward to 2025 and Google hasn't stopped. Their newest quantum processors exceed 200 qubits with improved error correction. That means we're no longer talking about party tricks. We're entering the territory of real-world applications. Fact 2, IBM plays the long game. From Eagle with 127 qubits in 2021, to Osprey with 433 qubits in 2022, to Condor surpassing 1,000 qubits in 2023, IBM has built momentum. But what really sets IBM apart is accessibility. Through the IBM Quantum Cloud, students in universities, startups, and even hobbyists can experiment on real quantum machines. Imagine if, in the 1970s, Intel had opened its semiconductor labs to the public. That's what IBM is doing now, creating an ecosystem before the real boom hits. Fact 3, India enters with sovereignty in mind. In 2024, Bengaluru-based startup QpiAI unveiled QpiAI-Indus, a 25-qubit superconducting quantum computer built entirely in India. Sure, 25 qubits seems small compared to IBM's 1,000, but here's the difference. India isn't outsourcing its core tech. Why does that matter? Because control over quantum technology is also control over security, finance, and science. For India, this is about sovereignty. The same way it built its own space program and vaccine production, India is now planting a flag in quantum computing. Fact 4, why quantum is different. Classical computers work in bits, 0s and 1s. A quantum computer uses qubits, which can be 0, 1, or both at the same time thanks to superposition. Add entanglement, where two qubits act like they're connected across space and time, and suddenly computations explode in power. While a classical computer solves problems one path at a time, a quantum computer explores all possible paths simultaneously. The result? Exponential speedups in solving problems that would otherwise take centuries. Fact 5. The challenge? Errors. Qubits are unbelievably fragile. Imagine balancing a spinning coin in the wind. That's a qubit. A single vibration, photon, or magnetic fluctuation collapses it. This fragility leads to errors. That's why error correction is the holy grail. Google recently demonstrated scaling logical qubits, error-protected units that stay stable even when physical qubits fail. IBM's answer? Modular quantum computing, linking smaller, stable processors together into a giant machine. Different paths, one goal: reliability. Without it, quantum computers remain toys. With it, they become world changers. Fact 6, the defense dimension. For India, quantum is not just science, it's security. Quantum communication using entanglement enables data transfer that's fundamentally unhackable. Try to eavesdrop and the act of measuring collapses the state, alerting both parties instantly. India, through ISRO, has already tested quantum key distribution between satellites and ground stations. In a world where cyber warfare is just as important as missiles, this is the kind of leap that keeps nations safe. Fact 7, follow the money. McKinsey estimates that by 2035, quantum computing could unlock over $1 trillion in value across industries. Google, IBM, Microsoft, and Amazon are pouring billions into research. India, by contrast, has taken a different approach, funding the National Quantum Mission with Rs 6,000 crores, supporting universities and startups simultaneously. Instead of betting on one horse, India is growing an entire stable. Think of it as building an ecosystem rather than a single company. Fact 8. It's not always a fight, it's a network. IBM runs the quantum network, partnering with universities across continents. Google publishes its breakthroughs in open papers. Indian scientists work with global peers on post-quantum cryptography. This mix of competition and collaboration mirrors the early days of the internet, built by rival labs but connected by shared protocols. Fact 9. The dark side: encryption collapse. Today, every secure system, from your WhatsApp messages to your bank transfers, relies on classical encryption like RSA. A sufficiently powerful quantum computer could break them in minutes. That's why governments worldwide are racing to adopt post-quantum cryptography, encryption that even quantum machines can't break. India's banking sector has already begun pilots with quantum-resistant algorithms. Fact 10. Who's ahead? Let's call it. In raw power, IBM leads with scale, over 1,000 qubits. In innovation, Google leads with error correction breakthroughs. In national strategy, India leads with sovereignty and resilience, ensuring it doesn't depend on foreign giants for a technology that could decide future wars and economies. In truth, this is not a sprint, but a marathon. Google surges forward with dazzling sprints, IBM holds steady with endurance, and India quietly carves its own path, ensuring no one nation monopolizes the future. So what does this mean for us? Imagine a world where new drugs are discovered in weeks, not decades. Where weather models can predict cyclones with life-saving accuracy. Where traffic in megacities flows without jams. Where new materials for batteries, engines, and spacecraft are engineered atom by atom. This is not science fiction anymore, it's the logical outcome of winning the quantum race. And here's the real twist. This isn't just about which company or country wins. It's about how humanity chooses to use quantum power. Will it become a tool for solving global crises like climate change and pandemics? Or will it deepen the digital divide, empowering only the richest nations? This is a question we'll all have to answer in the coming decade. The future is quantum. The future is already being written in Bengaluru, in California, and in IBM's labs. And as always, the question isn't just who wins, but what we all do when the future arrives. This is beyond binary. If you found this journey into the quantum race insightful, make sure to hit like, subscribe for more explorations of the world's most advanced technologies, and share this video with someone who loves learning about the future. And tell us in the comments, who do you think will take the lead? Google, IBM, or will India surprise the world? Beyond binary decoding tomorrow, today.